Algebra 2, we're dealing with our last lesson in this first part of chapter 7. You can see the very big difference here. It says the fifth root of x to the 11th. The fifth root. Now, we dealt with square roots yesterday. I'm going to show you a couple ways to do this. First off, the most direct way would be to literally write out 11 x's. And that can be a little tedious. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It'll just take you a moment to do that. But the bottom line is this. You have a fifth root. Because it is a fifth root, that's telling you look for groups of 5 of the same thing. So you count 1, 2, 3, 4, 5, and you can circle it. You go 1, 2, 3, 4, 5, and you circle it. Whatever you circle, that's what you can take out. So whenever you've got 5 of the same thing, you can pull one of those out. So how many x's are going to come out? My question is, how many circles do I have? 2. So you could see very quickly that you'd get x squared. Now please watch out. It's a fifth root here, not a square root. One of the number one mistakes that kids make is that they'll just write a square root here. And if you do that, you're going to get it wrong. Alex is going to say, hey, that's not correct. You're going to have to be careful to make sure you're writing the fifth root. There is a little button, and it kind of looks like this, where it's got a little box in that radical. So you're going to have to select that and make sure that you're typing out a fifth root. If you start with the fifth root, you end with the fifth root. Okay? Now, listen, I totally get that kids could say, hey, Mr. Dobner, this is kind of tedious to write out 11 x's. And it is, right? Now, before, when you went back to the beginning of the week, we divided, didn't we? Yes. Now, let's go back to elementary school. If you were dividing 11 by 5, you'd say, how many times does 5 go into 11? You'd say 2. 2 times 5 is 10. And you'd minus. Do you remember when you do that R1, there's 1 left over? Oh, yeah. Right? That means there's 1 left over inside the radical. Right? And that means 2 of them are going to have to come out. So that's another way you could look at it. Okay? So hopefully that can help you out. Some kids might say, hey, is it okay if I just write it out and write circles and pull it out? You bet. Definitely. Other kids are like, hey, I kind of like that method. You can do that too. Hey, let's take a look at problem number 2, though. It's mixing it up. You're going to have to break down the 96. And guys, remember, you're going to have to make a prime division tree. The primes are numbers like 2, 3, 5, and 7. And we start with this 96. And guys, always start, if you can, with the smallest number of 2. And 96 divided by 2, you'd say, well, that's 48. Try a 2 again. 48 divided by 2 is 24. Try a 2 yet again, you get a 12. Wow. Try a 2 yet again. 12 divided by 2 is 6. One more 2, and there it is. Wow. This one right here was kind of extensive. You don't always have numbers that are that big, but you will occasionally. So what are we getting at? We're saying, look, inside this radical, we'd have 1, 2, 3, 4, 5 2's. We'd have a 3. And then if you want, you could literally write out 9 x's. Like you have a group of 3, and a group of 3. Now, that's what a lot of kids like to do, especially since it's how you would have learned to do it with square roots. It's just that now you're not looking for groups of 2, you're looking for groups of 4. And kids will say, well, how do you know you're looking for a group of 4? It's a fourth root, right? So you'd say every time I've got 4 things all in a row that are identical, I'm going to circle. And I come over here, I could say, well, let's see, right here would be 4 x's. I'd get another 4 x's over here. And then you'd say, well, I've got one circle of 2 out there, so that means I can only pull 1, 2 out. How many x's are going to come out? Well, I've got 2 circles, right? So I'm going to get x squared. Those are the only things that are coming out. What you don't circle remains inside. So you've got a 2 times 3. Let's simplify that. 2 times 3 is a 6. And what else didn't I circle? An x. And you are done. Okay? We doing okay with this? It's very much the same mentality. It's just that instead of looking for groups of 2, you look for the number of groups that the radical tells you to. So, if you had a 5th root, like number 3, for example, that means you're going to look for 5 of the same number. Now, with the 243, it's not even. And you could say, well, my gosh, what's the next prime number? It's 2. Let's try a 3 this time. And as the numbers get a little bit bigger, it's going to be 81. You bet. Some of you probably just did that in your head. 24 divided by 3 is 8. 3 divided by 3 is 1. But you get 81. Keep trying the smallest prime number that you can. Work with a 3 again. 81 divided by 3, well, you could use a calculator if you want. You'd get 27. Try a 3 again. 27 divided by 3 is 9. I almost made a mistake there. And one last 3. So we've got 1, 2, 3, 4, 5 3s. 5 3s, right? So we've got 3 times 3 times 3 times 3 times 3. And you could say, well, I need 6 x's. 1, 2, 3, 4, 5, 6. And I'd have 12 y's. Wow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yikes, that's nuts. That's why I showed you that division relationship. Maybe it's easier to work that out. But, hey, I'm looking for groups of how much? 5. Hey, I've literally got 5 3s right here. That's kind of cool. And let's see, I've got 1, 2, 3, 4, 5 x's right here. And I've got 1, 2, 3, 4, 5 y's right here. I've got 1, 2, 3, 4, 5 y's right there. Okay? So what's going to come out? Help me with what's coming out. A 3. What else is going to come out? An x, because I circled an x. How many y's? 2 of them. Y squared. What's left inside? What didn't I circle? X and a y. You got it. Please remember when you type in your radical, it's got to be... Was it y squared? Thank you so much, guys. Appreciate that. Demon dollar indeed. We'll get one in a minute. All right, good. Okay, so are we doing okay? Again, please watch out. You want to make sure, guys, that you're writing a 5th root, not a square root. The other thing, sometimes kids will say, oh my gosh, that got so tedious writing out the 12 y's. I mean, do I need to write that out? No. Look, you could have just said, what's 12 divided by 5? You would have said 5 goes in twice. 2 times 5 is 10. Just like you learned back in 3rd grade or whatever it was, you would have said remainder 2. 2 y's would remain inside, 2 y's come out. See that? And you could do that with all your powers. Okay? We doing okay? All right. So last one, and then we're through, okay? You look here, and kids can, maybe get a little intimidated, but let me tell you the truth. This is not as bad as it first looks. 5 is prime already. 15, if you look at your primes, okay, 1 second. Okay, with 15, we want to check, our other primes. Obviously, 15 is not even. We want to start looking at the next smallest prime number, like a 3, and sure enough, that's 3 times 5. So please understand, these are second roots, and this is a second root, but this 15 is really 3 times 5. Now, here's the cool thing. you can make these two radicals just one. You can condense them all together. And you could say, well, look, I've got a 5, a 3, and a 5. Well, you could just say, put those all together. You'd say, I've got 1x, and then I've got 2 more x's right here. Say, I've got 7 y's. Wow, I've got 1, 2, 3, 4, 5, 6, 7. And then I've got 4 y's. 1, 2, 3, 4. Wow, you put those all together, and then you just break it down like you have been. But now we're looking for groups of 2. So every time you've got 2 of the same thing, circle it. And yeah, there are going to be a lot of things you're going to circle. Okay, so what number comes out? A 5. A 3 isn't circled, right? The 5 is circled. 1x comes out because I just have one circle with an x. How many circles do I have with y's? Yeah, look at that. 1, 2, 3, 4, 5. So I'm going to have y to the 5th. Now, what's still inside? 3x. What else? And a y. The 2. Well, the 2 is the index. I mean, you don't normally type that in. By the way, if you would have done the thing that we were doing before, radical with the box, if you would have put the 2 in there, Alex would give it to you. Okay? All right, so guys, that's what we've got going on.